Hello everyone, hope you guys are good. Let's see some counting formulas in this lecture. Multiplication formula. Consider this scenario. If you have 7 shirts and 5 pants, then how many different outfits can you make? How many possible pairs could you make to wear a different combination each time? This question wants us to figure out all the possible ways or arrangements of two things doing together. According to multiplication formula, total number of arrangement is equal to m into n. To understand this formula, if you pick first shirt, then you can have 5 choices of pants, 5 outfits with the first shirt. And if you pick second shirt, again you have 5 choices of pants. So in this way you have 7 times. You can do it either way. If you pick one pant, then you can have 7 choices of shirts, and in this way you will have 7 5 times. Adding 7 5 times means 7 into 5. And you can extend it to 3 items. For example, having 4 different type of hats, then we will have 7 into 5 into 4. Logo designer made a logo with a text, symbol and background color. He provided his client 4 type of font options, 3 symbol options and 7 background color options to use in a logo. How many different design options the client has? And now we have 3 group of objects. Each font can have a combination with 3 symbols. 4 3 times gives us 12. And for each of these 12 combinations, we have 7 background options. Adding 7 12 times, 7 into 12, and all the possible ways of combining them is 4 into 3 into 7. What is permutation and when we use the permutation formula? We use the multiplication formula when there were 2 or more group of objects. When there is one group of objects, we will use the permutation formula. Let's understand it with the help of an example. And let's make it more interesting by taking example from the comedy movie, Isn't It Romantic? In one of the scenes, a guy wrote his cell number on flower petals in random order and he threw those petals inside the lady's hat. And that lady was totally perplexed and she replied in something like that. Do you realize that there is 3.6 million permutations of how this could go together? For example, in movie it was more than 7, but for our example we are taking 7. The numbers are in random order and we don't know the perfect order of the digits. So how many different possible orders or sequences are possible for these 7 digits? For the first place, we have 7 choices to choose from. It could be any one of the 7 digits, but when we choose the number for the first place, we cannot repeat that number in the other places. Because this is a phone number and we have to choose digits from the available options. For the second place, we have 6 choices to choose from. After consuming the second choice, we have 5 choices for the third place and 4 choices for the fourth place. Any 4 of these numbers can occupy this fourth place. 3 choices for the fifth place, 2 choices for the sixth place and 1 choice for the last place. So 5040 possible arrangements are there for these digits. Another example is also very interesting from Mr. Bean's holiday. Because of Mr. Bean, a son was separated from his father, leaving the father behind on the platform. Mr. Bean and that boy waited for the father's train at the next station. But the train doesn't stop at the station and father holds up his mobile number, but the last 2 digits accidentally remain covered. Now how many different possibilities are there for the last 2 digits? In the movie we can see that Mr. Bean wrote every possible digit to call and find the perfect digits. He started from 00, 01, 02 and so on. For the first digit we can choose any number from 0 to 9. So there are 10 choices for the first digit. And in the same way we can choose any digit from 0 to 9 for the last place. And this gives us 10 into 10, 100 ways of filling up the last 2 digits. If we have to arrange 8 people in 8 seats, how many sequences of their sitting arrangement is possible. Any of the 8 persons can occupy the first seat. So we have total 8 choices for the first seat. When the first seat is occupied, we have 7 choices for the second seat. After filling the second seat, there are 6 choices for the third seat. And in the same way, our choices are reduced with every next seat. Or in other words, the number of ways of filling the seat reduces by 1 for every next seat. This creates a principle of n factorial. N factorial is the product of all the numbers between n and 1. So if we have to arrange 8 people in 8 seats, it is simply 8 factorial. I have taken a same scenario again, but will give you a visual representation. If I have to arrange 4 people in 4 seats, how many sequences of their sitting arrangement is possible? The answer is 4 factorial. For the first seat, we have 4 options. Anyone can occupy the first seat. But for the second seat, we have 3 choices. And then when the second seat is occupied, we are left with 2 choices. And there is just 1 choice for the last seat. Let's see it visually. If you have these 4 members, every member will get a chance on a first seat. There are 4 ways to start a problem by assuming each member on a first place. When this member is on a first place, then the rest of 3 are candidates for second place. If this arrow cap person occupies the second place, then we have 2 choices for the third place. If Mr. Ribbon got the third place, then only 1 option is left for fourth seat. If flat cap person got third seat, then ribbon person will occupy the fourth seat. In the same way, we can repeat the process if we choose ribbon person for the second seat, and then again we have 2 choices for third seat. In other words, 2 ways of completing the last 2 seats. This tree diagram reveals 6 ways starting from this lady. And if we draw a diagram for other 3 persons by assuming them on first seat, then each tree diagram will reveal 6 ways like the first one. It was just for understanding. There is no need to draw the rest of the diagram. But this diagram showed us the underlying principle of what we are doing here. For example, the first 4 choices when multiplied by 3 gives us 12. And we can see that all arrangements at the first and second stage totals 12. Then each of these 12 arrangements actually have 2 other ways of completing the 4 seats. This is the question from the last lecture in which before calculating the probability, we actually calculated the total number of tickets by multiplying 10 3 times. Because for every digit we have 10 choices to choose from, 0 to 9. Now we change the criteria for finding the total number of tickets. We have to select digits without repetition. For example, if we have selected 0, we cannot select 0 again. In the previous scenario, selection at the second stage is not dependent on the first stage and our options are not reduced. For the first place, we have 10 choices to choose from. And what we have chosen at the first place, we cannot use it again at the second place. So our choices are reduced. And for the second place, we have 9 choices. And in the same way, we have 8 choices for the third place. Permutation formula is actually applicable to this scenario, where we have to choose without repetition. So here comes our definition. So we can say that the number of sequences of R objects chosen without repetition from a collection of n objects is, this is our permutation formula. In this case, n is equal to 10. We have a pool of 10 objects and we are choosing 3 at a time. So R is equal to 3. We are dividing the numerator with n minus r factorial just to cancel the excessive numbers in the numerator so that we can retain these values 10 into 9 into 8. You can solve a question in both ways. In MCQ based exams, use this method. In an office, the secret cupboard has code consisting of 3-digit options and 3 alphabet options. Each digit has to be chosen from 0 to 9 and each alphabet has to be chosen from A to F. How many possible codes could be generated to open the cupboard? So in this question, we can repeat the digits and we can repeat the alphabets. We have 10 digits for each 3 places and we have 6 alphabet options for next 3 places. Against your ATM card, you have to generate 4-digit code. How many possible options you have to choose from? For every place, we have 10 options, 0 to 9. And applying the multiplication principle, 10 raised to power 4. In permutation, the order matters. If we change the order of objects, it will provide us the new permutation. While in combination, objects are considered a group, a collection, and changing the order doesn't affect the group's identity. ABC is equal to BAC. This is the formula to calculate the number of combinations. How this formula is different from the permutation formula? We have this R factorial in the denominator. And we should understand that what this R factorial is actually doing. If we have n is equal to 6, A, B, C, D, E, F and R is equal to 3, selecting 3 objects at a time. If we select A, B, C, so this is one combination. R factorial means that how many arrangements of this one combination is possible. And we can see that there are 6 possible orders or arrangements for this one combination. So by dividing with R factorial, we are actually eliminating their permutation counterparts. We are just retaining the original combinations. So this is the logic behind this formula. There are 3 employees, A, B and C, and a company wanted to group them in 2 for fieldworks. How many groups can we make from these 3 employees? The question is so simple that you can visually do it and you can see that there are 3 groups. Now plug in the values in this formula and verify the answer. Now in the word problems, you should be able to differentiate between the permutation question and combination question. A teacher has to select CR, research assistant and disciplinary prefect from a class of 20 students. How many different possibilities can be made from 20 student class? A teacher has to make 3-member group to participate in assembly, turn by turn, from a class of 20 students. How many groups are possible? This is permutation question. CR, research assistant and disciplinary prefect are creating different identities. Changing the order is actually changing the roles and thus creating a new permutation. Solve these questions by your own.